Hi folks, welcome back to the last video for the 8.6 and 8.7 series. And so in this video, we're going to focus on eliminating the parameters and write each equation in rectangular form, all right? So we're focusing just on the algebra and less on the graphic. All right, here we go. Let's start with number 6 here. So I want to get rid of the t's, right? That's sort of my end goal. But this is a good chance to remind ourselves of what it means to have a negative exponent, okay? So if I had, and let's do a little example here. If I had x to the negative 2, I hope we know that that's really 1 over x squared, okay? And if we had like x to the negative 7, that's really 1 over x to the 7. But if we had 3x to the negative 8, that would actually be 3 over x to the 8, because the 3 doesn't have a negative exponent, only the x, okay? Now, how might we use this over here in our x equation? Well, maybe we could express this as x equals 1 over e to the t, all right? Now, we have 1 over e to the t. Let's see if we can solve for e to the t. If I can get e to the t all by itself, I can plug that back in right over here, all right? So let's multiply both sides by e to the t. So x e to the t equals 1. And now I'm going to go ahead and divide both sides by x. E to the t equals 1 over x. That means everywhere, let's choose a different color, everywhere I see e to the t, I can replace it with 1 over x. So I'm going to grab my y equation. Y equals 3 times 1 over x, okay? And we should simplify that to be 3 over x. And there, I have an equation that has no more x or no more t's, so we're good. We've eliminated the parameter, okay? Now, this might look familiar to us. We learned way back in one of the first units that we did about the graph 1 over x. Turns out that 3 over x is going to be something like this. But this point, the one that's closest to where the asymptotes meet, that's actually going to be root 3 comma root 3. And this one is going to be negative root 3 comma negative root 3. Okay, so we've gotten rid of the t's, but we've also turned it into a form that we know how to graph. All right, great. Let's move on. Let's take a look at x of t equals 3t minus 2 and y of t equals t plus 1. Now, I might remember from video 2 that because the t's have the same power, they both have power 1, okay, because they have the same powers, what we have is actually going to end up being a linear equation, okay? So we can do this a number of ways. I'm going to take the y equation and I'm going to get the t all by itself, okay? So y equals t plus 1 is really t equals y minus 1. Now, that means that everywhere I see a t, I can put a y minus 1, right? Let's stick to our color coding here. So this t right here, I can put y minus 1. X equals 3, y minus 1 minus 2. All right, I'm going to go ahead and distribute. X equals 3y minus 3 minus 2. X equals 3y minus 5. Okay, now this is something that we might call, whoops, that is the wrong first letter, an implicit solution, okay? Implicit just means that I didn't get y all by itself yet. It's an x equals, or maybe the x's and y's are all mixed together, right? Once you get to some higher level math, it's okay to leave things in an implicit solution sometimes. So if you ever hear that word, it just means you don't need to solve for y. okay? I am going to solve for y just because we're in pre-calc, and I think it's important to make sure that we are remembering our algebra. Okay, so I'm going to add 5 to both sides, and I'm going to divide by 3. So 3y equals x plus 5, y equals x plus 5 over 3. But if I wanted to write this in a way that's more like, oh, this is my slope and this is my y-intercept, maybe I have 1/3 x plus 5/3. Okay, then this would be what we call an explicit solution, all right? Meaning we have it solved for y. We've got y equals something, 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 okay? And from here, we know it's a line. Slope is 1/3 and the y-intercept is 5/3, okay? All right, let's move on to example 8 here. Oof, got some logs and some square roots. Looks kind of gross. That's okay. All right, this is kind of the point of this. So here's what I'm going to do. I'm going to take this equation, I'm going to solve for t, and then whatever I get, I'm going to plug into the y equation, okay? So x minus 2 equals square root of t, and now I'm going to square both sides, okay? Now, here's something I don't want us to do. If you do this, you're showing me you don't really understand what x minus 2 squared is. I'm going to pause for a moment here because I know some of us watching this video make this mistake, okay? You cannot distribute the power, okay? You cannot distribute that power when you have a plus or a minus in there. That plus or minus, this is the entire reason we can't distribute the power. If that minus sign wasn't there, we could totally distribute the power. But we need to be really attentive to that detail. A minus sign, a plus sign, it means we need to FOIL, but we cannot just distribute the power, okay? All right, let's take this, plug it into our other equation. Y equals log of x minus 2 squared, okay? Now, we just did the log unit, right? So we might remember this is really base 10 here, right? Or if you were like, Judy, we also learned about some log properties, you could write this as y equals 2 log of x minus 2. That would be fine also, okay? So either one of these helps us understand what our graph looks like. Maybe, though, this one tells us a little bit more because that's our A value. That's our vertical stretch of 2 with a horizontal shift of 2 to the right, okay? So that's why something like this is actually really powerful, because it helps us figure out what something like this looks like, okay? All right. Last example here before we talk about some shortcuts, all right? Ooh, we've seen something kind of like this before, except this number and this number were exactly the same, right? They were both 5. But now we have one that's 4 and one that's 3. So we're actually going to start off similarly, but then we're going to stop a little bit sooner than we did in that other example, okay? So sine t equals x over 4. Cosine t equals y over 3. And I'm going to plug those into my sine squared t plus cosine squared t equals 1. And I'm going to end up with x squared over, x over 4 squared plus y over 3 squared equals 1. Okay. Now, I just made a huge fuss about you better not distribute that power. But I'm about to distribute the power here, and I'm about to distribute the power here. Well, how come? I hope it's not because I'm a hypocrite. The reason is we have a minus sign here. But over here, no minus, no plus. No minus, no plus, only multiplication or division. That means we can distribute. Okay. Now, I'll give you another spoiler alert. This is the equation for something that we call an ellipse. Okay. We're going to learn about that in chapter 10. But something of this form will be something that we can easily grab. Okay. Whereas something like this breaks it down into the horizontal and vertical components, but doesn't necessarily help us graph it right away. So that's why we want to start to learn these shortcuts here. Okay. All right. Shortcuts as promised. How do we know, just looking at these complicated equations, what it's going to look like? Okay. So I've broken this down into a few categories for us. It turns out if x and y have the same degree, so I've got 3 different examples here, and in every single one of these, we have the same degree. It turns out we are going to get a linear function. Okay. Now, it turns out that if the degrees of x and y are just half of each other, so for example, 3 and 6, 1 and 2, this I think is meant to be, we could actually make this 3 halves, that would actually work, okay? Or we can make it 6, but if one of them is half of the other one, right? Or 4 and 2, you're going to end up with a quadratic. And we know that a quadratic means we have a parabola of sorts. All right. If we have a case where it's a number cosine t and a number sine t, or the other way around, but noticing that these numbers are the same, so both 3s or both 2s, we're going to end up with a circle, all right? And last but not least, if we have a case where like one of them is one number and the other one is another number, okay? So we have 2 different numbers in the front, but we still have sine or cosine. We're going to end up with an ellipse. Okay. Now, here's one little last bit of extra credit here. You'll notice that I gave you the shape, but I didn't give you the direction. And so for extra credit, if you'd like, I'd love to hear your ideas on how you know which direction the curves are going in, and maybe even how you get the graphs to change the direction in which they're traveling. Okay, so that's the last little bit of extra credit for 8.6 and 8.7, and hopefully I'll see some of you in office hours, all right? Have a good day.